Good morning to Muhammad Anwar bin Idris. Today we are going to present about vector and scalar. We are from group 4. Our group members is, first is me, Yoganathan son of Mageswaran. My metric number is 01DKA21F1049. My another member is Muhammad Hafiz bin Nazri. His metric number is 01DKA21F1046. The course code is DBM10013 Engineering Mathematics. Now we are going to see what is the vector and scalar. Vector is a quantity that has magnitude and direction. For example, gravity. Scalar is a quantity that has magnitude only. For example, mass. Scalar does not have direction. Vector and scalar. These are examples of scalar and vector quantity. The scalar quantity has only magnitude. These are the examples of scalar quantities: length, area, volume, speed, mass, density, pressure, temperature, energy, entropy, work, and power. These all are scalar quantities because this all does not have direction. A vector quantity has magnitude and direction. Vector quantities, for example, is displacement, velocity, acceleration, momentum, force, lift, drag, and height. These all have magnitude and direction, so these are called vector quantities.
Like, why should we know about vector and scalar? First, everything that we do from driving, driving a car to striking a perfect kick in football has vector and scalar involving in them. It is possible for us to do what we love without involving vector and scalar. How, how to use vector and scalar in solving engineering problems? In sport, such as rugby, vectors are used to calculate the distance, angle of trajectory, and the direction needed to shoot a perfect goal.
Now we are going to see a question and its explanation. Okay. This is the question. The picture shows a rugby field. Okay. This is the explanation of the picture. A kicker attempting a field goal 50 meters away from the goalpost. The height of the goalpost is 16 meters. At what direction and what distance does the kicker need to kick the ball to score a field goal? Okay, now we are going to find what direction and the distance does the kicker need to kick the ball. We see a triangle which is ABC. This triangle is shown and taken from the rugby field. To find the magnitude and directions, firstly, x-axis equals to b equals to 55 meter, y-axis equals to a equals to 16 meter. Okay. To calculating the magnitude, there are one formula. The formula of calculating magnitude is c square equals to a square plus b square. C equals to square root 16 square plus 55 square equals to square root 3281. So we get the C, which is magnitude equals to 57.28 meter. Next, we are going to calculate the directions. For direction, we use the trigonometry method. Tan -1 equals to y over x. Tan 16 meter over 55 meter. Tan 16 meter over 55 meter equals to 0.2909. So equals to the direction is equals to 16.22 degrees.
Okay, how about we solve another problem? Okay, for this picture, as you can see, a basketball player is standing 8 meters away from a basketball hoop and attempting to gain a score for his team. If the height of the hood is 3 meters and the height of the player shoot the ball is 1.8 meters, at what angle and how far should the player shoot the ball to make it in? Okay, next is solving the problem. For solving the problem, I will explain in Malay. First, pertama, cari magnitude. Y sama dengan 1.2 meter, manakala X sama dengan 8 meter. Magnitude sama dengan punca kuasa 2, 8 kuasa 2 tambah 1.2 kuasa 2. Sama dengan punca kuasa 2, 65.45. Masukkan ke dalam kalkulator dan anda akan dapat 8.03 meter. Okey. Sekarang kita perlu mencari direction. Untuk cari direction, theta sama dengan tan negatif 1 y per x. Theta sama dengan tan negatif 1 dalam kurungan 1.2 per 8 tutup kurungan. Theta sama dengan tan negatif 1 0.15. Akhir sekali, jawapannya akan dapat theta sama dengan 8.53 darjah.
Finally, last but not least, this is our conclusion for our presentation. Vector is very important in our daily life as an engineer. So we know that vectors are also used in engineering to represent quantities that have both a magnitude and a direction. Many engineering quantities such as forces, displacements, velocities, and accelerations will need to be represented as vectors for analysis. That's all from us. Thank you.